I'm a developer, consultant, and trainer, and I'm the CEO of 500 Tech. So I'd like to start with a question. Who agrees with this? Raise your hand if you agree with it. Now everybody's afraid, like, I don't want to agree. Okay, so for me, Redux is a single source of truth, is a misconception. So Redux gives us a single store, and it gives us the option to have a single source of truth, but it's our job as developers to keep this principle. And I will demonstrate it later in my talk. So in 500 Tech, we started using Redux when it was just starting. And we built dozens of projects using Redux, and we learned a lot from each one. And I hope I can share some of our experience with you. So I will share some common mistakes that I see that people do, common mistakes that we did in the earlier projects, and some tools and our best practices to solve them. And I hope that it will fit your needs as well. And I want to give you a warning. This is an opinionated talk, so you might disagree. Feel free to boo if you see something you don't like, or cheer if you see something that you really like and use. Yeah, like this. You just demoed it. Let's give it an attempt. So, Redux. I heard some boo. Okay, so let's start. So for handling immutable data, which is something we have to do in Redux, we use Lodash-FP. I didn't hear any boo, so I'm okay. Who uses Lodash-FP? Oh, a few of you, it's okay. It shares a very similar API, except all the functions, instead of giving the object in the beginning, we give the object in the end, and we have other things from functional programming, like the functions never mutate the object that we give them. It's always immutable, and we can do auto-carrying and stuff if you know functional programming. And as you can see, the code is very concise, and it's very readable. As opposed to using, for example, plain ES6, which is very verbose and introduces a lot of boilerplate. So Lodash-FP will allow us to keep our objects immutable, but nevertheless, sometimes we can make mistakes. If we don't use Lodash-FP or nothing forces us to use it everywhere, we can make mistakes like this. Take a second to read the code. So basically, the first line of code creates a shallow copy of the state. And the second line is very naive, is saying, okay, we have a new copy of the state, I can just change a property. But since we're changing an inner property, we're changing the original state, because we didn't create a deep copy of the state. And it's very hard to see that there's a bug. You have to go deep into it. Also, there are third-party libraries that sometimes take an object and then mutate it. And you don't really know that they're doing it. So in all these cases, you will have bugs that are really hard to debug and detect. Trust me. We spend hours trying to debug these, mainly because when you look at the Redux DevTools, you don't see any diff between the states. Like you see an action, you see that the reducer is doing something, but there is no diff between them because we broke immutability. So I know what you're all thinking. You're thinking immutable.js, right? No, okay, I like it. Who thought Redux Freeze? Okay. Redux Freeze is a small library that it's very simple. What it does is deep freezes your state after every action. Freezing is something you can do on objects in JavaScript, which means that if anyone tries to mutate the state by accident or by purpose, they will get an exception with the line of code that tried to mutate the state, so it can protect us from mutating the state, which is good. Now, we use it only in development because we don't really need it in production. We just need to make sure in development that we don't mutate the state, which means that we don't even get any performance penalties in production for introducing this. Now, the reason we don't use immutable.js is because our approach allows us to have plain objects, which means it's easy to serialize or deserialize them and persist them to local storage, load them from local storage, and integrate them with other tools. And we also have a rich and familiar API of Lodash. That's why we don't use immutable.js. So whatever you do, don't deep clone the state. I've seen people do it because it's the easiest way to create a new copy of the state and not mutate the original. So it's pretty obvious, but let's understand why it's so bad. Not because deep cloning takes such a long time, it's just an object, we create a copy, but because all of the components that require these properties will think that something changed and they will re-render. I don't have the animations here, so I have to look. And so that's the problem with deep cloning. It's very not performant because we have to re-render our components. If we just change the path to the property that we want to change, like we should in immutable data, only the components that need to re-render will re-render. Now, if you don't like functional programming, you can use Immer, which Michelle introduced. Yay! Here's the author of Immer. Woo! Yeah. So we use Lodash FP because we really like the API of Lodash, and as I showed you, the code is very concise, more concise. But Immer has other advantages, like it works better with TypeScript, so it's another alternative that I recommend checking out. Basically, it gives you a draft state that you can treat as a mutable object. You can do whatever you want with it, and Immer will will apply all the mutations that you did using proxies. Okay, so our reducers. They're pretty simple. We use handle actions from Redux Actions library, and they help us avoid switch cases. Pretty simple. They also work really good with TypeScript because they allow us to use the specific action type inside the handler, because each handler is a function, so we can specify different action types, which is nice. I like. We use selectors. Who doesn't use selectors? Okay, so for those of you who don't use, this is probably the best thing you can take from this talk. Selectors are a way to encapsulate access to the store. So instead of every component that needs something from the store, instead of just accessing the data directly, they call a function that accesses the data, and then if the type of the state changes or names of properties change, we can just change the function in one place. We don't have to change every component that takes data from the store. So sometimes this concept, people know it, but they don't implement it. So implement it. So basically, we have two types of selectors. If we just need simple access to the store, we write a plain function. Function takes the state and returns some kind of value from it. And if we need something more complicated, like a computed value, a filter of objects in the store, some kind of transformations of the data, anything that requires more CPU power and time, we use reselect library, which caches the result. But we don't use it for every selector. If we just need to take some data from the store, reselect introduces boilerplate, which we usually don't need. So if you don't need it, just use a function. It's okay. I didn't include it in the talk, but you should also check reselect. It's an actual library. Reselect has a problem of it has a cache capacity of 1. So then you have to do things like selector factory to return new selectors, and reselect helps with this. Or use Mobix. So now I'm getting to the part of the question that I started with, that Redux doesn't enforce single source of truth. Now for me, the only thing that enforces a single source of truth is marriage. But Redux gives you the option to have a single source of truth, but it's up to you to enforce it. So let's take this example, and I've seen this mistake done a lot of times, and it's one of the biggest mistakes because, well, let's get to it. So let's take this reducer. It saves a list of products on the state, on the store. But it also saves a list of active products. So it's a sublist. It's the same list filtered by some criteria. And this criteria is also on the state, on the store. Which means that basically we don't have to keep the active products on the store as well. We can derive, we can calculate the active products whenever we need them. Which means now we have 2 copies. If we did what I just showed, we have 2 copies of the state, not identical like here, but one can be derived from the other. So maybe twins is not the best example. Which means that now we have to keep these 2 copies in sync, or 3 copies or 4 copies. So one smart person once told me that copying data is more destructive than deleting data. Because if you delete it, it's gone. But if you copy it, now you have a lot of copies to make sure that they are in sync. So when you use a selector, you simply calculate it whenever you need it. And this is our map state to props. And we just call the select active products, give it the state, and we get the active products. And because we're using reselect, then we get caching. Thank you. I'm just making sure you're alive. Are you alive? Who's alive now? Okay. All the dead people, please get out. Raise your hand if you feel like raising your hand. Okay. So we always keep our reducers, our selectors, sorry, separate from our reducers. I've seen some people put them together. And the reason is because a selector might access data from different locations in the store. And we don't want to limit it or couple it with the reducer. That's why we separate them. That's one of the true powers of Redux. It doesn't encapsulate access to the store. It lets us be more flexible about it. So the way we handle side effects, async flows, API calls, etc., is that we write middlewares, like an API middleware that takes care of all API requests to the server. We don't use any of this, sorry, because in our opinion, they either overcomplicate the code more than, like the cost is bigger than the value, or they give too much power to the developer in the wrong places. So like an action creator can do whatever it wants. So then you get action creators like this. And also when we use middlewares, it allows us to have much more reusable code, and I'll show later exactly what I mean. So we don't use any of this. I didn't hear any boo, so okay. I guess I'm the first speaker who asks people to boo at him. Okay, let's talk about state design. Hi, mommy. So let's look at an example of a list of users that we fetched from the server. And the user can select them using checkboxes. So basically, we have server data coming in, and we have UI state, which the user selected. So the way we store it is we separate server data from UI state. So in a user reducer, for example, we will just have the users that came from the server, and we don't touch the data because it came from the server. So in this case, the server is the real source of truth, and we just have some kind of copy of it. And notice that we keep it in a dictionary, not in an array, and it's keyed by the user ID, and it allows us to easily access a specific user by its ID. And the user selection, we won't save it on the user object itself, because then we mix server data with UI state. So we will keep we'll keep it separate in its own reducer, or the same reducer but different property. And it's basically a dictionary of which user ID is it selected or not. And that's it. So why is it good? If we need to reload the data from the server, for example, we change filter, we change the page number, whatever, then we just take what comes from the store, overwrite from the server, overwrite whatever's in the store, and that's it. We don't have to worry about overriding the user selection. And also, if we need to do things like save and restore the UI state from local storage, for example, it's much easier to do it this way. It's much easier to debug it and to access the data because, again, it's flat. It's not hidden somewhere inside the user object. Who agree with me so far? Okay, nice. Who doesn't? Okay, get out. I will be here later, so if you want to tell me I'm wrong or debate with me on it, I will be glad to. So finally, and I think I will be a little early, so maybe I'll start speaking slowly, is code reuse. So how do we reuse code in Redux? This is one of the pain points, I think, in Redux, especially for beginners, that everything that you have to introduce to Redux takes a lot of boilerplate, and you just want to get over with it and think, okay, maybe I can do something more infrastructure here and reuse it in some other places. And I see a lot of code duplication. So let's take a very simple example that pretty much every app has, which is a loading indicator, some kind of spinner, progress bar, and whenever there are pending API requests. So this is how we would solve it if we were naive. We would have, let's say, a user reducer that handles API requests to the server to load, let's say, a list of users, update them, create them, whatever. Let's say we have a user management feature in our app. So this reducer will save, for example, a flag called isLoading, which is true or false, which means we have to update it whenever we send the action to get the data, and whenever the response comes back, usually we have another success action or error action, and then we update the flag to false. But then we have to repeat the same logic for every other reducer that loads API data from the server. Moreover, we have to repeat it for every action. So get jobs, update job, create job, whatever. So we repeat ourselves. So what is the solution? Say higher order reducer. So what is the solution? No, you're wrong. So what we have in our app, in our boilerplate, is a dedicated reducer just for this purpose, for saving loading state or network state, or how many pending requests are there. And we have just two actions, start loading and end loading. So basically, for each request type, which is just a string label, we save how many pending requests we currently have. And when this number gets to 0, we know that there are no pending requests. We can hide the spinner, enable the button, redirect to a page, whatever. So what did we do here? We took the same key that we had in different reducers and the same logic. And instead, we have one reducer with different keys, because we still need to know sometimes maybe we have requests to load one thing and requests to load something else, but we only care about one of these things, and we need to show a spinner until this request ends. So let's do a short walkthrough on how the middleware works for this, our API middleware. So first of all, it receives an action. It checks if it's an API action. If it's not, it just continues. And if it's an API action, then it gets here. So first thing, it just continues with this action. So let's say we try to fetch a user. So we release the action, fetch user. Then we dispatch the start loading action, which increases the counter of pending requests, and we give it a label. Now, this label came from the fetch user action. So this is the only thing we need to configure when we add a new API action to say which label that this belongs to. Now, if you only have one spinner on all of the screen and you don't need this resolution, you can have just one key and name it all. And then when everything stops loading, you hide the spinner. So it really depends on your app. So now the counter is 1. And then we make the actual request, either by using fetch or whatever. And when the data comes back, if we have a success, then we fire a success action, which was, I'm not showing it here in the code, but some kind of action that says, OK, we finished loading the user. Usually, this action will be called something like set user. So it's more explicit than fetch user success, because it doesn't show intent. Set user says, OK, I'm setting the user that came from the server on the store. It's more explicit. And only then we fire the end loading action, which reduces the number to 0. So it's important to first set the data on the store and then hide the spinners. Otherwise, the spinner will disappear, and only then the data will appear. The same we do for our catch. So if there's some kind of error, we dispatch maybe an error action, and then we also end the network request. Now, the same thing can be applied to different things. So let's say we have a notification if the API request was successful or not. We can also have this logic in the middleware or in another middleware that handles only this, and have a dedicated reducer just for this. So you mentioned higher order reducers before, and I'm glad you did, because usually when people talk about code reuse in Redux, the first answer is higher order reducers. For us, it's the last answer. What higher order reducers do is that it's kind of like higher order components. They take an existing reducer and add functionality on top of it. So you can have with loading or whatever. And sometimes you need it, and it's unavoidable. Sometimes you have to have separate reducers that do things similar. But we always try to have, if it's similar functionality, then we have one reducer that handles it. The problem with higher order reducers is the same with higher order components. It's really hard to understand what the code does, because you see the reducer, but you see that it has a lot of other things, and you have to go to that file and see, oh, okay, so it's this reducer, but it also handles these actions. Okay, so now I understand the reducer better. Okay, let's see what with tags does. Okay, it also does something else. And also you can have name clashing of keys. So if the same higher order reducers, different higher order reducers use the same keys, then they will override each other, and also bugs that are really hard to detect. So it's okay to use them, just carefully and only if you really need to. So most of what I've talked about is in our boilerplate, which is on bitbucket.org/500tech/React Redux project boilerplate. Hopefully, we will also have a React Mobix project boilerplate one day. And feel free to send us an email if you have better suggestions or you think we don't know what we're talking about. If you're really into Redux, I recommend these two books. The Complete Redux book, very complete, as the name implies. Just learn about everything in Redux from beginner to super advanced. And also Thinking in Redux, which kind of, it's not exactly what I talked about. It's a different way of thinking, but it also opens your mind, and it talks a lot about middlewares. I will give a Redux masterclass in the near future. So you probably got tired of hearing me, but if you have friends that want to come, recommend them to go to React.il meetup and check out my masterclass. So, thank you.